So in this video, we're going to look at kind of the classic application where we have two vehicles moving towards each other, and we can ask different questions about those two vehicles. We can ask, when will they meet? Where will they meet? How fast are they traveling? And the only assumption that we have going into this is that the vehicles are traveling at constant rates of speed. And because they're traveling at constant rates of speed, we get to assume that distance is going to equal the rate that they travel at times the time that they've traveled. So this particular problem, let's go ahead and read it. It says two cars leave towns that are 600 kilometers apart. They leave at the same time and they travel towards each other. One car's rate is 12 kilometers per hour less than the others, so we have a slower car and a faster car. And it says if they meet in 4 hours, what is the rate of the slower car? So I'm going to start by drawing a picture. So we start at one town, we have another car starting at another town. So I'm going to say car 1 starts here, car 2 starts here. So I'm going to have to catalog information about car 1 and car 2 so I can set up my relationships. And I have to decide which of these two cars I'm going to make the slower car. And it doesn't matter which one you choose. So I'm going to make car 1 the slow car, which makes car 2 the fast car. And then they're going to meet. And if car 1 is the slow car, he will have gotten not quite as far away from his town as the other car has. So they'll meet somewhere closer to town 1, which is where car 1 started. And there's going to be a distance. I'll call it distance 1. That's traveled by car 1, the slower car. And there's going to be a distance. I'll call it D2, traveled by the faster car. And we are told that the distance between the two towns is 600 kilometers. And so right away from this picture, I can extract some information. I see that distance 1 plus distance 2 adds up to 600 kilometers. And this allows me to express the distance relationships two different ways. I could choose to subtract distance 2 from both sides, which would isolate distance 1. So distance 1 would equal 600 total miles minus distance 2. Or I could subtract distance 1, from both sides, which would tell me that distance 2 was equal to 600 miles minus distance 1. So there's a couple ways to express the distance relationships. So I have a slow car and a fast car. They each are going to have a rate or a speed. So I'm going to let the rate of the slow car be rate 1 and the rate of car 2, the fast car, be rate 2. Notice I'm subscripting these. They're subscripts. And we know that the slow car is going to be 12 kilometers per hour slower than the fast car. So the rate of the slow car I can get by taking the rate of the fast car and subtracting 12. I could similarly take the rate of the fast car, rate 2, and I could get the rate of the fast car by taking the rate of the slow car and adding 12. So there's a couple ways to relate our rates to each other. The slow car, distance 1, travels distance 1. The fast car travels distance 2. But we also see that there are a couple ways that we can describe distance 1 and distance 2. Distance 1 is also 600 minus D2, and D2 is 600 minus distance 1. So there's different ways that these things can be described in terms of each other. And they are each going to have traveled some length of time, but we're told that they travel the same length of time. So we know that T is going to equal 4 hours for each of them. Sorry, it's getting late at night. So for each of the cars, the distance equals rate times time relationship is going to hold. So I know that distance 1, the distance traveled by the slow car, equals the rate of the slow car times time. And I know that the distance 2 traveled by the fast car is going to equal the rate of the fast car times time. I know that these two things are true, and if I want to, I could just as easily write this so that the 4 is in the coefficient position because the order of multiplication doesn't matter. So it might be a little bit convenient for me to switch the order of multiplication and write r sub 2 times 4 as 4 times r sub 2, for example. And here's where you really want to pause once you've cataloged all of the information and say, what is it that I'm really trying to figure out? Well, we want to know the rate of the slow car. We want to know what is R1 equal to. Nothing else matters. So what I need to do is get an equation that only has the rate of the slow car in it. I need a single variable linear equation that only contains r sub 1, because r sub 1 is what I'm being asked to find. So when I look at this relationship here, this distance equals rate times time relationship, it has r1 in it, which is what I want to find. So I'd like to leave this alone. When I look over here, I see that it has rate 2 in it, the rate of the fast car, which I don't want. So the question is, can I rewrite this rate so that it is written in terms of what I want to know, the rate of the slower car? And I can, because if I look up here at this relationship that I wrote down, I see that the rate of the fast car can be described as 12 kilometers faster than the rate of the slower car. So I can make a substitution here. I can say, hey, d sub 2 is going to equal 4 times the rate of the fast car, but I can rewrite the rate of the fast car as r sub 1, the rate of the slow car, plus 12. And now I don't have the rate of the fast car anymore. I only have the rate of the slow car showing up in 2 spots. The issue right now is that I still have 2 other variables. I need a single variable equation that only contains the unknown that I'm interested in, which is the rate of the slow car. So I need to find a way to get rid of these distances, which are things that I don't want. So the other thing that I can notice is that this distance 2 right here can be rewritten in terms of distance 1. And if I can get a distance 1 here, and I have a distance 1 here, if I can isolate distance 1, I can set 2 equations equal to each other. So I'm going to replace this distance 2. I'm going to make a substitution and say, hey, this is the same as, distance 2 is the same as 600 minus distance 1. Now I have 2 variables. And now I have 2 variables going on. The variable I want, the rate of the slow car, and distance 1. So now if I can isolate distance 1, here distance 1's already isolated. If I can isolate distance 1, I can set 2 equations equal to each other. So my next move is going to be to subtract this 600 from both sides, which is going to leave me with minus distance 1 equals 4 times rate 1 plus 12 minus the 600. And then to get distance 1 by itself, I'll multiply both sides by a negative 1 to get a positive distance 1 here. So I have to multiply both sides by negative 1. And if I do that, I get negative times negative is positive distance 1 equals. And this negative will distribute into the 4. So I'll get negative 4 times rate 1 plus 12. And then I get negative times negative is positive. So I get plus 600. So now I have distance 1 isolated. And I isolated distance 1 because it is a variable I'm not trying to figure out. And now I'm going to take distance 1, which is equal to 4 times rate 1, and I'm going to set it equal to the other distance 1 right here, which is equal to negative 4 times rate 1 plus 12 plus 600. And now I have a single variable equation because it only has rate 1, and it's linear because rate 1 is only to the first power. Now I just solve it for rate 1. So 4 times rate 1 equals, distribute the negative 4 into the parentheses. So I get negative 4 times rate 1, negative times positive is negative, negative 48 plus 600. I'm going to get all of the rate 1s on the left-hand side, so I'm going to add 4 rate 1s to both sides. 4 rate 1s plus, I add it to both sides, so I get 8 rate 1s, or rate of the slow car, 8 times. I get negative 48 plus 600 is going to be 552. And then I can divide both sides by 8, because 8 divided by 8 is 1 rate 1. Rate 1 is equal to, and now I just need to do this division. And I don't have a calculator handy, so I'm just going to do the division. So 8 is going to go in there 6 times and give me a 48. 55 minus 48 is going to be a 7, so I get 72. 8 times 9 is 72, so no remainder. So I get the rate of the slow car is 69, and now I need units, but it's going to be, units are going to be kilometers per hour. So kilometers per hour, kph. There we go.